If f of x is equal to x squared minus 2 and g of x is equal to 4 times f of x minus 1, then which of the following is the value of g of negative 3? So the first thing you need to do is rewrite the equation given for g of x in terms of f of x. So g of x is equal to 4 times the value of f of x, which is x squared minus 2, close the parentheses, minus 1. Now substitute negative 3 in for x. Put that in the calculator exactly the way that you see it, and you should get the result of 27. If a function is defined by the formula y is equal to 1/2 x plus 3, and its domain is given by the set negative 4, 0, 8, then which of the following sets gives the function's range? Okay, so we know that the domain is x and the range is y. So we're just going to set up a table, 1/2 x plus 3, and get our y values, the domain, or you could put this into your calculator graphically and look at the domain and range using the table. So as you can see, the range is 1, 3, and 7. So the distance d that a car has traveled as a function of time t is given in the table below. What is the average rate of change of the distance over the interval 2 is less than or equal to t, which is less than or equal to 9? So you're going to have to plug it into the formula. It's been a little while since you've seen this, but you should still know it at this time. Okay, so the distance over the interval in between and including 2 and 9. So average rate of change we know to be the change of y. My pen does not want to write. So we're going to plug that into the formula. 498, don't forget it's the y values first, minus 106 divided by 9 minus 2. Put that into your calculator exactly the way that you see it, and you'll get the output. So the answer is 56. So for the function g of x shown graphed below, over which of the following intervals is g of x greater than 0? This means the same thing as y is greater than 0. So where are all the values for y greater than 0? Up here. Okay, y is equal to 0 is right here at this line, the x-axis. So right here at the x-axis is where y starts to be 0, and as we go up for y, that's where it starts to increase. So from here up to here is the interval where y is greater than 0. So 1, 2, 3, 4. The choice that best fits this interval looks like it's choice 2. For the function defined by f of x, and this is a piecewise defined function because we see the bracket right there, which of the following represents the value of f of 2? So since the value of x is 2, we have to look at the domains here. And the one where this fits into the domain is where x is greater than or equal to 1. So we're going to plug it into 10 minus 5x, that equation. So 10 minus 10 is in fact equal to 0. For the function g of x graphed below, over which of the following intervals is g of x decreasing? So where g of x is decreasing is where it's falling. And that looks like it's right in here. So the two x values that this is in between, oops, that's not going to work. It's kind of small here, so I'm not sure if I'm going to be able to get it. It starts at the x value to the left of the y-axis at a -1, it looks like, right there, bingo. And then we look to the right, it goes all the way down, it looks like there's a turning point right here. So that is about 1, 2, 3 spots to the right of the y-axis. So in between a -1 and 3. Given the graph of the function f of x shown below, which of the following intervals represents its domain? So domain represents x values. So we start on the left here, which is about 1, 2, -3, including -3, and we're going to the right of the y-axis, 1, 2, not including 2 because of the open dot. So the interval that includes in a -3 with a bracket is choice 1 and doesn't include 2 with a parentheses. A function is initially defined by the set of coordinate pairs -3, 7, 1, 5, and 4, 13. Which coordinate pair below, if added to this set, prevents the set from representing a function? Okay, so how do we know we have a function? Well, if we look at coordinate pairs and we have no x value repeating, then we say it's a function. So to make it not a function is to pick a coordinate which does have the same x value. So you guessed it, it is choice 4, because we have 1, which is the x value that's repeating in the domain given up above. If the function x of x is defined by h of x is equal to 2x squared minus 7x minus 12, then which one of the following values of x solves the equation h of x is equal to 10? Now I'm not going to have this on your test, but it doesn't hurt to refresh your memory on quadratics from before. It is a function, so it does apply. So they're telling us that h of x, the whole entire equation, is now equal to 10. You should recognize that this is quadratic. All quadratics have got to be equal to 0 if we want to use quadratic formula. In this case we will, because I see this bigger coefficient here next to the squared term. A is equal to 2, B is equal to -7, C is equal to a -22. Go ahead and plug it into quadratic formula. x is equal to a negative b plus or minus square root b squared minus 4 times a times c all over 2a. So x is equal to positive 7 because we have a negative 7, and when you plug it into a negative b, it becomes positive, plus or minus negative 7 squared minus 4 times 2 times the negative 22 all over 2 times 2. Go ahead and do the math. Work on what's under the radical first, and then move towards the outside. So when you simplify what's under the radical, you end up with 225. That's a perfect square, and that is equal to 15. So we end up with 7 plus or minus 15 divided by 4. At this time, we need to split that up. So I am going to go up here because I ran out of room. I have 7 plus 15 divided by 4, or 7 minus 15 divided by 4. So this is going to end up to be a negative 2, and this one's going to end up to be 11 halves, or 5.5. So you're probably wondering how I got 11 halves. That is the correct value. When you add 7 and 5, you come up with 22, and you divide by 4, that is a fraction, and you reduce it to 11 halves, also known as 5.5 decimal equivalent. And as you can see, the answer that we need is a negative 2. So what are the next 3 terms of the sequence? Well, when I evaluate these numbers, I can see that each one is being multiplied by 3. So all I have to do is multiply 27 by 3 in order to get the next number, which is 81. Multiply that to 3 in order to get the next number. We get 243. Multiply that by 3, and we get 729. And as you can see, that's choice 1. Okay, so we have the first 3 terms of the sequence. If I count up the shaded squares in the pattern, 1, 2, 3, 4, 5, 6 times 2 is 12. 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 is 20. So term 1 needs to be 12, term 2 needs to be 16, and term 3 needs to be 20. So I'm going to substitute my values for n for each of the terms into these given equations and see which one gives me an output of 12, 16, and 20. So 4 times 1 plus 12, that definitely can't equal 12 as the first term, so this isn't going to work. 4 plus 12 is equal to 16. So that's out. 4 times 1 plus 8 is 4 plus 8. That's equal to 12. 4 times 2 plus 8, that's equal to 16, so this works. And 4 times 3 is 12 plus 8 is equal to 20. Bingo! We hit the jackpot in the second step, so we're good. Choice 2 is the obvious answer. A sunflower is 3 inches tall at week 0. Okay, so let's represent that. F of 0 is equal to 3 and grows 2 inches each week. Which function shown below can be used to determine the height f of n of the sunflower in n weeks? Okay, so since it's growing 2 inches each week, I can represent that as f of 1 is equal to 3 plus 2 is 5, f of 2 is equal to 5 plus 2 is 7, and f of 3 is equal to 7 plus 2 is 9, and so forth. So I'm going to substitute my terms 0, 1, 2, 3 into each of these equations and see which one gives me the same sequence of numbers. So 2 times 0 plus 3 does equal 3, so we're good. 2 times 1 plus 3 is equal to 5. That works. 2 times 2 is 4 plus 3 is 7. And 2 times 3 is 6 plus 3 is 9. So 1 works. Now let's check Roman numeral 2. I'm going to do that one up top. So 2 times 0 plus 3 times 0 minus 1 is equal to 0 plus 3 times a negative 1. That's a negative 3. Second one does not work. Now for the last one. This one is a recursive sequence because it wants to use the value of the last term. We're also given the value of the first term. So since we know this, we'll just write it. We're going to substitute into that recursive sequence the value of 1 is equal to, take the last value, 3, plus 2, that's equal to 5. Now with the second term is 5 plus 2 is equal to 7. Now the third term is equal to 7 plus 2 is equal to 9. So this works. Okay, so 1 and 3 work, so that's choice 4. The function f of x is shown graphed below. The function g of x is defined by the formula g of x is equal to negative 4 times f of x plus 7. What is the value of g3? Show the calculations that lead to your answer. So they've graphed the function f of x, and they're giving us a value for x in order to solve in the function g of x. So what I'm going to do is use that value of 3 in the function f of x, and I'm going to locate 3 in the domain, and I can see that this is the point right here. 3, negative 1 is the value for f of x. So using negative 1, that output, I'm going to plug it into g of x. So that's equal to 11. Which of the following graphs represent a function? Explain how you arrived at your choice. So we're going to perform the vertical line test, and if we draw a line, a vertical line that is, anywhere on this graph, you will see that it will only hit in one spot. So this is indeed a function. However, when we draw that on this ellipse here, we get 2 points of intersection, therefore we have to reject it as a function. So it's not a function. Caitlin has a movie rental card worth $175. After she rents the first movie, the card's value is $172.25. After she rents the second movie, its value is $169.50. After she rents the third movie, the card is worth $166.75. Assuming the pattern continues, write an equation to define A of n, the amount of money on the rental car after n rentals. Okay, so if you look at all the numbers here, we start with this, we start with this, we end up with these two. Okay, so what did we do to all these numbers to get these results? We subtracted $2.75. Yes, you guessed it. Okay, so Very simply, the equation for our function is equal to, you start off with $175 and you subtract $2.75. That's times n. Now Caitlin rents a movie every Friday night. How many weeks in a row can she afford to rent a movie using her rent-a-card only? Explain how you arrived at your answer. Well, this equation has to be greater than or equal to 0. So we're just going to solve for n. Subtract 175 from both sides. And divide out a negative 2.75. However, something has to change with the inequality sign. And hopefully you remembered that it was the direction that has to change. So we get 63 with 63 repeating. So Caitlin can rent 63 movies. We have to round down. If we go over that to represent the 0.63, then she's not going to have enough money. So if we set the equation greater than or equal to 0, because we know she's going to have to purchase more than 0 movies, and it's not equation inequality, greater than or equal to 0. And she can only rent 63 movies, or she will go over her limit of $175. And that concludes this review.